So what can I say? The error in linear measurement is, what is that error? E. And the error in angular measurement, what is that? Please speak.
Delta theta.
Delta theta. Angular measurement. This is theta. Delta theta, sorry. So if I say this is 90, so if I say this is D, if I put this point D1, so what can I write? Can I write DD1 equal to, what can I write? Let me know. What will be DD1? Hmm?
So it's C.
नहीं, D यहाँ पे D है ना? This is T, ये D1. So if I want to write DD1, if I know this delta theta, then what can I write here?
L delta theta.
L tan ये लिख सकते हैं?
Tan से tan से.
Yeah. So now, if you're using the chain and compass, so what is our requirement? Okay, I think I discussed in the long back. Now you will get the answer. Whatever if you are using the two instrument, one is measuring the angular measurement, another is for the your linear measurement. That's why they should have the same precision. Okay, same degree of precision the two measurement. It should be. So can I write your this E equal to L tan theta, this condition? It means I want to say here the two instruments should have same degree of precision in measurement. Okay, so what can I write here now? If I want to write it theta tan inverse,
So how E is equal to L tan delta theta?
that's why I'm telling to you. What I'm saying, I'm measuring the theta with the compass and length with the L. Okay, so these two instruments, the different utilities there. One is measuring angular, another is measuring your length. So it should give the same degree of the precision. Okay, in survey, what we want? Okay, if error occurs in your theta, if you if I'm doing some error, delta theta, I measure. So the same proportional error should come in the E. That is our requirement in the survey. So whatever error I am doing in linear measurement, it should be equal to your in linear measure in your angular measurement. Are you getting my point?
Yes, sir.
Okay, otherwise it is a mismatch. There is not a compatibility of the instruments. You want to, it means the instruments should be incompatible with each other. They should, okay. Anybody's doubt for this point? Please let me know. In a sense, what I want to say, in survey, the error in the angular measurement should be same as that error in the linear measurement. Okay, because the degree of accuracy depends upon the type of instrument used for linear and as well as for the angular measurement. Have you got my point?
Yes, sir.
So now, if it is so, now if I say my linear measurement instrument has the accuracy of 1 upon 5000. You are doing the survey, okay, and somebody says your linear measurement instrument should have this accuracy 1 upon 5000. So now it's up to you what angular measurement instrument you will select. So what should you do? You should calculate del theta tan inverse 1 upon 5000. What does mean if I this is a linear measurement instrument? What is the meaning of that 1 upon 5000? It means if I measuring 5000 meter, there should be error of 1 meter. The meaning of that, if I'm measuring 5000 meter, there can be error of 1 meter. So the delta theta, how much you will get? Anybody can calculate? Give me the value.
Sir, it's 0.11 degrees.
Okay, convert in the minutes. Can you do?
Sir, 0.66 minutes.
No. 0.66 कैसे आएगा? Tan inverse 1 upon 5000. Anybody?
Sir, 41.25 seconds.
Yeah. Around, if I say around 41 minute, can I write 41 second? It is coming for anyone?
Yes,
So what
yes,
does mean? If you are using the instrument linear measurement that have the error of 1 upon 5000, okay, it is the precision in the linear measurement. We explain in that way. The precision of the linear measurement is 1 upon 5000. So what will be the precision of, should be the precision of your angular measurement? So it should be 41 second. For that, now you have to use the instrument that has the precision of this much. Got my point? If you want to use the angular measurement for this linear measurement, the instrument should have this type of least count. You got my point?
sir. So this is the answer of the chain and prismatic compass.
Yeah, I'm coming to that. I'm coming to that. So now we are using the chain. What is the accuracy of chain?
20 centimeter. Yes.
20 centimeter. Okay. Now, if you see the total error of the, it should vary from 1 upon 300 to 1 upon 600. In, if I, in normal condition, if I use the chain, this is the accuracy. Now for this, you was just you calculate 1 upon, you calculate this value, calculate an inverse. This is your delta theta. You can convert it. What is the value?
The first one is 11 minutes 27 seconds.
11 minute. Or here,
Uh, the 5 minutes 43 seconds.
5 minute.
43
Okay.
seconds.
When it will come around 30 minute. It means I want this delta theta 30 minute. So tan inverse. Nee, so you just find the tan 30 minute value. It will give you the linear measurement now. It will give E by L. It is you can find the accuracy. Now, if you want, it is vice versa. If you want to use the compass of 30 minute, then 10 30 minute I have to find what is E by L.
0.577.
Is just giving the one upon situation. Just make it. जाएगा?
So 1 by 114.
1 by
114.
114. So you see, you are very close. Okay, so this range. So what you understand? Can you explain me what you understand by all this thing? Can you make me understand? Anyone? What you understand so far? Please let me know by this concept what you understand. Hello.
Sir, for prismatic compass of 30 minutes
Hmm.
chain, it should be 1 by 1 and 114.
Okay, so that's why we are using the chain here. Now your question is that if you want to use the tape, tape has the accuracy of, if you see the accuracy, it has the accuracy of this in this range, 1 upon 10,000 range. It means if you measure the 10,000 meter, it will give the 1 meter error. So now you calculate 10 inverse 1 upon 10,000. How much you're getting?
20 seconds.
20 seconds. 20 seconds. So remember, if somebody is using for traverse making, you want to use the this type of tape, because tape have the accuracy of this precision in this fashion, then you have to use the instrument that has the angular measurement precision of 20 seconds. What is that instrument? We have to use then theodolite. Because what is the least count of theodolite?
20 seconds.
20 seconds. So that's then you can comply with this statement. You're the if you're doing the two measurement, the error between the angular measurement as well as the error in the linear measurement should be equal. This is called the compatibility. We are discussing the compatibility of the students. Compatibility of instruments. Have you got my point?
Yes, sir.
Got it? So that's why I asked you the question. What you written in the exam? I also asked that question in the exam. 42 points, no? What you write there?
Sir, wrote something like this only, like 30 10 theta, but not completely correct.
Okay, I will see. No problem. So these are the things you should consider. Okay. So as we discussed in the last class, okay, there is some define for compass survey. The maximum error of the closure should be. If you see in the last class, we have discussed now. Limit of closing error in the compass should not exceed 15 minute under root n, where n is the number of sides. Okay, now your traverse says suppose n equal to 5. So just calculate this figure 15 minute under root 5. What will be? Just give me the value. I don't have calculator right now. 15 minute under root 5. How much you get?
33.541.
Huh?
33.541.
Convert in the minutes. 33 minute.
So this is minutes only, 33.54.
Yeah. That's why we have the This count of compass is 30 minutes. Designed in that way. Now you can find the E by L. So then it should be your accuracy should be your linear measurement. This is the concept. Now, if I move forward, the new chapter is now theodolite traversing. Okay, so you have seen the videos of theodolite. I think you got something. What is the concept? How it works? Basically, the theodolite used for. If you remember something, let me know. This instrument used for
Measuring angle.
measuring
Angle.
which angle?
Angle
Sir,
between two points from a reference point.
Hmm? Be specific. You say you horizontal angle. We can also measure the vertical angle. Okay, that experiment we have done by there's a two method, reiteration and repetition. I will not going in that detail. Okay, I will just after 5 minutes I will just focus on numericals. Okay, if you see the books, what is happens sometimes is also written. With the theodolite, we can also you measure the magnetic bearing. Why they write so? Because what you have learned, the magnetic bearing, if you want to use, I have to use the compass. But if you see in the book, they also use the theodolite can be used to measure the magnetic bearing also. Suppose you want to make this angle, I can easily, if I the theodolite is T, this is your A or B. I want to measure this theta. But in book, it is written. If you any book, I can also measure the magnetic bearing. How?
sir, so take one point at north.
So I will tell you what is happening in theodolite. Na, there is some attachment. We can put the trough compass there. We can attach the trough compass. So when I'm measuring this A, it will also give the north of this A. I'm also knowing the north of this A. So there is some attachment. This is called trough compass. Okay, that I can attach to the theodolite. Okay, then I can able to measure the bearing of any line, T A line. I can able to measure the bearing. So your answer should be we have to use the trough compass. Then we can use the measure the magnetic bearing. Okay. Now what are the points for the temporary adjustment of the theodolite? Let me know.
The leveling, that one. Centering, leveling, focusing.
What is the temporary adjustment?
For centering, leveling, and focusing, that one.
So how we do centering? Tell me.
So by plumb bob and that tripod and that bubbles from the theodolite.
So how we do centering? With help of which instrument?
Sir, plumb bob and tripod.
Plumb board and tripod. Then what next we do?
Leveling.
Okay, good. Leveling by
So the spirit, what the bubbles are there.
huh?
So from those bubbles,
Be loud, be loud. With help of
so that bubbles on theodolite.
so you have to say we have the 3 foot screw.
Yes, sir.
We have 3-foot screw. By that we do. Okay, and after that what we do?
Sir, focusing.
After that,
Sir, focus on that ranging rod.
how to make it?
Sir, through that, what is it?
Anybody can complete the sentence?
Sir,
Sir,
crosshair.
Crosshair, but how to make that crosshair to visible?
sir, that lower
Huh?
screw we use.
Which screw?
Sir, lower screw.
No, no, there is not lower screw. I think you forgot the video. We have to focus the eyepiece that
Yes,
is
sir.
placed on telescope. Have you got the point?
Yes, sir.
Okay, and we have to remove the error parallax. What is parallax? Have you gone through the book or not? Anyone? What is parallax?
Sir, that object is visible like at different location.
Okay, so that error have to be removed by focusing the eyepiece
Yes, sir.
and focusing the object glass. Okay, so briefly, if I say again temperature adjustment, I can write for your understanding. The first is setting of the instrument. At station. What is number two? I'm just then have to do the approximate leveling. Approximate leveling by tripod stand. What was three? Then we have to do the centering. Okay, you can also start from centering, but if you see the by process, then first you set the instrument, then you do the approximate leveling by tripod stand. Okay, then we do the centering. Then number four, what we do then? Leveling, foot screw. What is number five? Five, focusing of eyepiece. What we do here? Here we using the foot screw. Here, so the eyepiece is focused so that the crosshair can be the crosshair. Crosshair seen clearly. So if you see the crosshair, have you seen in any photo of crosshair?
Yes, sir.
If you see the crosshair, if you focus the eyepiece, it looks like that. Okay. So we take the reading by this line. The different crosshair available in the world. Okay. So yeah, this is called upper stadia. This is lower stadia. Okay, that we use in the tachometry. Okay, not using the theodolite. So we have to do your ranging rod should intersect with this crosshair. Okay, when you focus in the eyepiece, your crosshair will be visible. Okay, so what we do to see this crosshair, sometime what we do, we put some white paper in front of the telescope So we're able to see this crosshair. Sometimes you have to do. Okay, there's no obstruction there. No? Now, what is 6? Focusing of object glass. What does mean? Let me know.
Sir, that ranging rod.
We want to see now our ranging rod. Okay, so we are now just moving our telescope in either direction and want to see that there should be clearly visible our object. Okay, that's why we move the object glass. This is done to bring a sharp image of the object or target in the plane of the crosshair. Okay, what I said, in the plane of the crosshair, we should see the sharp image of the object. That's why I use the do the object class. These are some temporary adjustment for every station we have to do it. So far any question? I think we have discussed in the lab class. If you listen there, then there should be no issue. If I say the transit theodolite, what you understand by transit theodolite?
So that can move in vertical direction also.
The telescope should move
In
in,
vertical direction.
in vertical direction. With non-transit, then
Then it will not move.
not move. Can you see some classical definition of non-transit theodolite? Anyone? Saurabh is there? Let me see how much present there.
Sir,
Yes.
non-transit is if it can't be rotated.
Okay. Along which axis?
Vertical.
Horizontal.
Horizontal axis. So you have to see very clearly. If it is rotated along the horizontal axis, then it is a transit. If it is not rotated, it is the non-transit. Then the two other different terms is a face left and face right. I think you know that one. What is face left, face right?
Clockwise and anti-clockwise.
No, face left and face right. What is face left, face right of theodolite? बोलिए सर. Anybody?
Sir, that what we call that angle of it is in right direction. In the face right
No.
and in left
If you
direction.
see the
Face left.
video, there is some vertical circle. If you see the
Yes, sir.
image of
That
the anybody is getting the point. If there is a vertical circle on theodolite.
yes, sir. That round one.
Okay, that round one. So that is the left side of the observer, there is a face left. If it is the right side of the observer, that is called the face right. We done like that, no?
Yes, sir.
Okay, good. Now, more things I will ask. What is line of collimation there?
So that horizontal line,
The
center one.
this line of collimation, how to define? Can you tell me?
Sir, horizontal line passing through the center
No.
of object glass. Hmm.
If you understand the things, you just see. Suppose I'm making this is your telescope, no? Here is your object lens. Object lens. Here is my eyepiece. Somewhere, if you see, here is the diaphragm. Okay, and their crosshair should be on this diaphragm. The diaphragm is a brass ring consisting of crosshair. Your crosshair should be some on the diaphragm. There is a crosshair. Okay. Now the line of collimation, if I define it, this imaginary line. It is passing through the intersection of the crosshair. If I draw a line, the line of passing through the intersection of the crosshair at the diaphragm and the optical center of the object glass. Okay, and its continuation. Okay, this is called the line of collimation. So what is the line of collimation? If the classical definition of that, the imaginary line passing through the eyepiece, center of the eyepiece, then what I told, passing through the intersection of the crosshair at the diaphragm and the center of the object glass. This is your line of collimation. So your line of collimation should be parallel to the, it should be parallel to the which axis?
Horizontal axis of telescope.
Yes, horizontal axis. So the horizontal axis of the instrument should be parallel to the line of collimation. Otherwise, what will happen? This is like that. Your instrument had some error. Your horizontal axis is supposed like that. So then it will be the problem. This error will become. Okay. So these are the things you should remember. For every instrument, the line of collimation concept is there. समझ में आ रहा है आप लोगों को?
Yes, sir.
Okay. मेरा राइटिंग समझ में आता है? मैं थोड़ा फास्ट लिख देता हूँ. Is it okay? Otherwise, write slowly. Hello.
Yes, sir.
Now, if you understand how to take the angles and how to measure it, then now, if you see, so I'm not going the methods, okay, that you have done. Okay, that is your lab part. Now, if you're making the traverse with the theodolite, there is a concept of closing error and its limitation. What is the definition of closing error? You just think and let me know. Give me 1 minute. So what is closing error?
Sir, when we have to make a close traverse, but there is some error at the final point,
Yes.
not meeting
So
the initial.
now with reference to your theodolite, suppose I'm making this A, B, C, D. So now What is happening? It is not closing. I'm making this dotted line. It is happening. Your A, this is A1. So I should say this is your closing error. This line. This line should be your closing error. So can I introduce the concept of some, if I say summation of L here, and here I am writing summation of D. So your L is means latitude. Latitude. D means departure. I will discuss what is latitude and departure. So can I write AA1 is equal to the under root of in this fashion, where L is your latitude, D is your departure. Can I write like that? Yes or no?
Yes, sir.
Yes.
Please let me know. Yeah. Any question? Anybody saying something? No question. Hello.
Yes, sir.
Okay. So if there is the summation of L is equal to summation of D, summation of departure, then what can I say? There is no no closing error. Okay, otherwise we have to find the closing error. So now our job is to we have to find the latitude and departure. How to find that? Here also can write tan theta. If the error in the measurement, the summation of D to summation of I. Okay, the theta indicates the what theta indicates? The direction of closing error. Closing error. So if it is equal, then there is no closing error. Now what happens? There is now some how to determine this L or D. So now the chapter starts the computation of latitude and departure. So now if I say this is my north, south, east and west, okay, and if I say this is my length L, okay, if I say this theta, it will also be theta, okay, so can I say this is L cos theta? It means it is latitude and this is L sin theta, am I right? This is departure. Is it okay? Yes or no? We define the latitude and departure in this fashion. If I say this is my point A and point B, is it okay?
Yes, sir.
Okay. If now you understand these things, now based on theta, if you understand this theta, so in this quadrant, your both the latitude and departure will be positive. Now, suppose theta comes this side. Now, if you calculate, then your this will be the positive, your departure will be negative. Depends upon theta. Where is our theta? If you come in the this quadrant, this is your first quadrant. This is your which one is second? This is your second quadrant. This is your third quadrant. I can say both will be negative. So just calculate it. Then here will be the minus L plus D. If you calculate by this theta concept, you'll find this. Okay, now question how to remember that. If I say again north, south, east, west, how to remember? How to remember? Anybody can tell me? Okay, before going further, if you understand here, the latitude of a line is the distance measured parallel to the north-south. Your latitude is always measured to the in parallel to the north-south, and your departure is always measured in the parallel to the east-west line. You just remember. Okay, your latitude will always parallel to the north-south, and departure will be parallel to the east-west. Okay. Now, if I further say, there is some other terms are also there. If I say northing, northing means the latitude towards north. If I say southing, then latitude towards south. If you see very clearly, again, if I say north side, what is happening here? The how to remember these things. If I say northing, northing means at north side all latitude will be positive. Okay? And southern side all latitude will be negative. Okay? Again, I have to write. And eastern side all departure will be positive. And west side all departure will be negative. Can you remember this lesson?
Yes,
Okay? Anybody can repeat? And north side, the all latitude should be,
positive.
and southern side, all latitude should be,
Negative.
and east side,
All departures should be positive.
and west side, all departure should be negative. You remember this concept, otherwise, there can be a problem in the numerical. Okay? You just keep in mind. Now, if you understand these things, then we have to solve some numericals. Let me give you a numerical. Any doubt? Please ask me. If any doubt, please ask me. So far, no doubt. Anyone? And give 1 minute time. What you understand? Let me know. Why we are introducing the concept of latitude and departure? Let me know.
So that we can find closing error.
So that we have found the closing error. What else? What we can do? We can use it differently. Now you'll see in the numericals. Okay. Now the one numerical I have to give you. Suppose I am making the traverse. the AB, BC. This is your, I can say, example. Just understand this very carefully, okay? AB, BC, CD, DE, and EA. The length, this is my, the length is given, this is the line, this is the length. If I say LENGTH, it is given in all in meter, okay? In meter, the 100 meter, this is 350 meter, this is 75 meter, this is given 52 meter, and this is given 318 meter. And the bearing, it is giving 30 degree, 30 minutes, 135 degree, 00 minute, 220 degree, 30 minutes, 240 degree minute, 310 degree, 15 minutes. It is given. If you see this bearing line is the whole circle bearing because it is varying from 0 to 360 degree. Okay, the question is that here find the closing error of the traverse. This is our main concept. Okay, you have to find this AA1. If you see the figure, I have to find the AA1. These data are given. Okay, how to proceed for this type of numerical? What I have is given here. See, I am considering the theta in the quadrant. So it means I am considering the quadrantal bearing. Am I right? Yes or no?
Yes, sir.
Okay. So first we have to convert this bearing to the in quadrantal bearing. I have to find the reduced bearing. So I have to find the quadrantal bearing first. So what will be the quadrantal bearing of this phenomena? Let me know. Tell me the quadrantal bearing of this.
So it will be 30 degrees, 30 minutes.
Huh?
So it will be 30 degrees, 30 minutes.
No, quadrantal bearing you have to give the north and south, na?
Yes, yes.
So it will be north. Am I right?
Yes, sir.
Now, what about this 135 degree 0 minute? Give the quadrantal bearing. Now I should ask Aslisha.
South 40.
Yes, sir.
What is the quadrantal bearing for 135 degree?
So east 45 degree south.
No, just always quadrantal bearing started from north and south. So you just interchange your this north and south. It will be the south 45 degree east. Always remember any quadrantal bearing should start from north and south.
Okay, sir.
Okay. Now what next? 220 degree 30 minute. Aditya. Aditya is not there. Okay. Abhinil is also not there. Amlipur.
Yes, sir.
Tell me that. If your whole circle bearing 220 degree 30 minute, what should be the quadrantal bearing?
South 40 degree 30 minutes west.
Good. So these things you have to do there. Okay, little things you have to be. So here quickly I should write here. This should be S 45 degree 0 minute east This will be south 40 degree 30 minute W. This will be W west. Now here will be the south 60 degree west. Here will be north 49 degree 45 minute west. Am I right? Now we have to find the latitude as well as the departure. Okay? Now make sure in which quadrant we are, north and east. Okay? For solving this numerical, okay? Now again, you have to remember the concept of sign convention of latitude and departure. So quickly I can write here north, south, east, west, sorry, minus L, plus D, minus D. You don't waste so much time for this one. I can write like that quickly. So now you let me know what is latitude here. This is north in east. So it means your latitude and departure both will be positive. So I have to, latitude means L cos theta, it will be your L sin theta. Quickly, can you give me the values? This is the L. L is given to you. Give me the first latitude.
86.16.
Always mention the sign. 86.16. Next, give me the latitude. It is southeast. So southeast. Your latitude will be negative, departure will be positive. So first I have to make the latitude will be negative and it will be positive. Give me the value.
Minus
50 point
70.71.
Huh? Give me value. Latitude for this BC. Be quick. What happened?
Sir, minus 257.48.
Minus 2. What should I write? Minus 2. क्या बोले आप?
Sir, minus 247.48.
48. And next.
so minus 57.03.
Minus 57.03. What about next? For this DE.
So minus 26.
Minus 26.0. Good. Then EA.
Plus 205.47.
Good. So likewise, you have to calculate the departure also. Let me know. If I do the plus, something plus will come.
Sir, plus 50.753.
50.75. Okay. Next.
So 247.
7.48.
Good. Next.
Minus 48.71.
Minus 48.71. Or next.
Minus 45.033.
03. I'm only taking the two digit, okay? Next.
Minus 242.70.
Good. Okay. Now you have done so far. So I have to add here summation of latitude and summation of departure. So the positive will be remain positive and I will subtract the negative. So I will get some value here. What value I am getting here? Let me know. You getting? I have to 86 minus 247 the summation. What value I am getting here?
Minus 38.89.
Minus 38.89.
Nine. Yes, sir.
Okay, here I will get quickly.
Minus 38.21.
So that we have done. Okay. Now here I have to write the correction for latitude. Correction for latitude. Latitude. And here I have to write the correction for departure. Yeah, I'll leave that there. Okay. So for line AB, I want to make some correction. Okay, because as we know, what you learn in the bodies, if you see this rule where I if you see the graphical method bodies rule, the every line should be shifted, no? So every line had some error, that's why there is some closing error. So for every line we have to do the correction. So for every line if you do the correction, then how can I use it? If you remember what we have, the perimeter, the first line is remain, याद आ रहा है आपको बॉडीज रूल? See, here we have learned something. याद आ रहा है आपको? Anybody?
Yes, sir.
Yes, sir.
Okay, so what we are doing there? The total error divided by what you done there? The concept of similar triangles you used to find the closing error. Okay, so same thing in mathematical form we will do here. Okay, for AB what can I write? Can I write to find the 100? 100 is the length of AB and the perimeter. If I want to know the perimeter of this traverse, if I make it sum, it will come around 895. Summation of length. So 895 will come the summation of this total length. So the 100 divided by 895 into what is the departure value is 38.89. What value you will get?
4.34.
4.34. This here again for the departure again you will do this correction. 100 upon 895 into, now it is 38.21. So we'll get around 4.26. So for every line you have to do this correction, because for AB, BC, CD, DE or EA. BC again you write 350 upon 895, 38.89, you will get 15.19. I'm just starting the value now, okay? 3.25 you will get 2.25, here you will get 13.80, and this side you will get BC equal to 14.91, CD you will get 3.20, DE you will get 2.22, and EA you will get 13.55. This value you will get. You have to remember, here will I put the sum of latitude, here should I put the sum of departure. Okay, this value you are getting. So the correction, so if there is no closing error, then what should be there? Okay, I want to remove the closing error. So what should be the concept? The sum of latitude should be equal to the sum of departure. If there should be no closing error, am I
Yes,
right?
sir.
So one question you will be finished here. You want to find the closing error. If I say E, you have to do the summation of this plus. So you will get around. You just calculate it. How much you are getting here? It is around. Tell me the value. How much?
Sir, 54.52.
Meter. This is the closing error. Now we have to check what. Suppose what is happening in survey now, what we are doing now, you can check whatever you're getting this value are correct or not. How to check it? Now for AB you got the correction 4.34. Now you see this is negative, so I have to add. Okay, it is also negative. So whatever I am getting, I should add. Okay, so for AB the correction is 4.34. So I have to add 4.34 where? In 86.16. So eventually it will be, so finally your AB will be your latitude and departure. AB will be your final will be 90.5. AB BC will be your minus 232.29. Why it becomes 232.29? Because your BC is 15.19. I have to add. So I minus 247.48 plus how much? 15.19. I have to add. So I will getting 232.29. Why I am adding? Why I am adding? Because it is negative. I have to balance it. You got my point?
Yes,
Hello?
sir.
Okay. So likewise, if you see the CD, you will get 53.78 CD, then DE, you will get minus 23.75, EA, you will get plus 219.26. Now you add it. You will see. You add it. Somebody should add it. I'm writing for departure. It should come. It should plus. 55.01, 262.39. You will come minus 45.51. Why I'm getting? Again I'm telling you. For CD, the departure is 3.20. I have to add it. For CD departure. CD departure is 48.7 m. I have to add how much I should add? 3.20. So I will get 45.51. For every length I'm doing the calculation. It 81 minus 229.15. Now you add the summation of departure, latitude, and summation of departure. You add how much you're getting here? Hmm?
Sir, summation of latitude is minus 0.06.
0.06. Here
Minus 0.07.
so it means your summation of latitude and summation of is almost equal. So now if you are doing by this length, there is no closing error. Okay, and we have found the closing error here. Okay, we have 54.52. It is the in the traverse, this much of error is there. 54.52. Okay, but if you correct it, then there will be no error. So by concept of latitude and departure, okay, we can find the closing error or we can balance our traverse also. We have to just redistribute the error. Are you getting my point? Any doubt? Just I'm doing one code. Please ask me. This is a long numerical. Okay. If any doubt, let me know. Any doubt? Any doubt? Any doubt? Subham,
No, sir.
you clear? Okay. So I'm giving you finally one numerical. Okay. You do it yourself. Okay. Okay. I will ask you in the next class. Okay. I'm just giving you a numerical. You just solve it. Okay. If you understand the concept, you have to solve the problem. Okay. You have to find what should you have to find? Line. This is length. This is bearing is given to you. Your A B B C C D D A is there. This length is 75.50, 180.50, 60.25. Okay. and I don't know, I forgot it, the omitted measurement. Okay, where the length of bearing of some of things I forgot to take. Still I can get with this concept. 30 degree, 24 minute, 110 36 minute, 210 30 minute, and I don't know about it. Okay, for DA line I don't know the length and the bearing. So question is that you have to find this. Apply the concept of latitude and departure. Okay, always remember the concept is that if there is close traverse, if there is a close traverse, there is no error, then your summation of latitude and summation of departure should be equal. By this concept, you have to find the this length of DA and bearing. It also called the, if you these see the other books, it is called the omitted measurement in the traverse. So this question I am giving to you. Okay, able to do it? The same concept. Yes or no?
Yes, sir.
Okay, remember this is whole circle bearing. Okay, so I'm giving you this question. Okay, I have some. So you will do it. You will send. You will discuss in the next class. I hope you
Yes,
will
sir.
do it. Yes or no?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, so this is enough for today's class. If you have doubt, you let me know. Otherwise, you will end for today. 2, 3 numericals we will do for this latitude and departure. Then straight way we will go for leveling. This is a long chapter. Okay, now things will little difficult. Okay, you just try to be focused. 83 students, only 54 is available. Out of 54, I don't know how many is there. Okay, so you just you will do it this numerical. Otherwise, I should solve it. What do you want?
We'll do it, sir.
Okay, you will do it. I want to know. Okay, then I will end for today. Okay, thank you.